So I'm recording the, forgot to start it right away, but. So we have a parent of a student and one of the coaches and a student from Ohio. Maybe indicate too whether you are flying the Wright stuff event or electric Wright stuff. Yes, the video can be shared later. AJ had the question. I'm recording it so that we can, I would imagine we can publish it out there on, what do you think, Chuck? Could we publish it like on the YouTube channel or?
We should probably get an okay from, at least a verbal okay from everybody that's, well, anybody that shows an image. I guess right now nobody's sharing an image, so it's not an issue.
Okay.
If we do get to where students are visible, we'll want to get their permission.
So Josh has two students, Bryce and Abby. And I think, did you say middle school, Division B? Yeah.
Yeah, we're Division B, we're doing electric.
Okay.
That relates to my first question. I noticed in the draft schedule for next year, Division B is going back to rubber powered Wright stuff. Is there a particular reason for the quick exit of the electric powered Wright stuff for Division B?
We haven't heard, but I suspect that Ward Scientific was unable to source motors and capacitors. And they're a strong driver for what gets done because they're the official supplier.
Interesting.
Yeah. Do you think that there's a leaning towards maybe shifting to electric for high school?
Now, high school is listed as helicopter.
Oh, it is. Oh, I'm sorry. I haven't looked yet.
Yeah. And last year they told us that Ward was saying we'll never go back to helicopter. So who knows?
Interesting. Yeah, I know that I think Chuck and I were in the same boat. We were ordering electric motors and propellers and things in the summer, hoping we'd get them in time for the teams. I think I spent probably $300 on electric components. Probably 200 of it are not usable.
Yeah, I've got a bunch of motors that I don't know what I'll ever use them for.
Yeah, they're probably great for drones.
Yeah.
So should we start?
Yeah, I think we'll get started.
Okay.
Okay. I'm going to just give a brief rundown on trimming, and then Brian will throw in any comments he has, and then we'll open it up to questions. And if anybody is in a gym and wants to have the group watch their plane fly and try to understand what's going on, we could do that too. But as we've watched the forums and the Discord site, we've seen that trimming the planes has been a particular issue. And we've also both ES'd a number of events. And we see very well-built planes this year that don't fly because they're not trimmed properly. So we thought we would start off with the seminar series on basic trim of these airplanes and see if we can get some improvements. We've also at the Austin meet, and I think Dave Lindley went to another meet and saw similar results. We had about 15 or 20 students show up on Sunday after the meet was over, and we did a hands-on workshop. And by the end of that workshop, everybody that came to the workshop had beat the first place time in both Wright stuff and electric Wright stuff on Sunday. So there's a lot of room to improve the trim of these airplanes. Our goal right now is to get you to where the basic trim is there and to understand what the different aspects of trim are on the plane. The first thing you want to do is make sure your plane is straight to begin with. That means you don't have warps in the wing, something like that. Sometimes you'll break a trailing edge or something and it'll be bent up at a funny angle. And then the tip plates, whether they're angled like our team does or vertical like most of the kits, they have to be on there straight. If those are canted to one side or another, it's at least drag and more likely going to impact the flyability of the airplane. Now, some of the initial things that we see on trim, the first is the center of gravity. And a lot of people will report their center of gravity relative to the propeller or front of the plane. What we like to do is report it relative to the rear wing post, especially on those kits such as the J&H, where the wing is on a movable carriage and can be repositioned relative to the motor stick. It's the center of gravity location relative to the rear of the wing that's important. These planes tend to want the center of gravity near the rear wing post, if not slightly behind it. I believe J&H in their video initially reported starting with the CG about 2/3 of the way back on the wing, and that makes a terribly nose-heavy plane. So in order to measure CG, we take a ruler, and I like to just hang the plane upside down and balance it on the ruler. And this one is about 1 centimeter behind the wing post. My understanding is the J&H kit likes to be right at the wing post. We have a longer tail boom than the J&H, and that allows us to move our CG back. That is a starting point. At the rear post or up to 1 centimeter behind is a good starting point. But once you start trying to perfect your trim, you'll move that a millimeter or two at a time. You're going to be in that range. So if your CG is well forward of the rear wing post of the wing, the plane is not going to fly well. Second, we want to look at some of the basic trim adjustments. And the first one is your wing incidence. Now, most of you on the tail, the stab is glued to the tail boom and there's no incidence adjustment. So basically the stab's set at 0, and you want to measure the difference between the leading edge and the trailing edge of the wing. I use a clear ruler, and we simply measure up, and we want to be consistent. We always use the bottom of the motor stick. We place the ruler against it with the 0 at the bottom of the motor stick. And this carbon trailing edge, we look at the bottom of that trailing edge. And this is 57 millimeters. And the front is 60 millimeters. So we are 3 millimeters different between the front and the back of the wing. And that's in the range of what we find a good starting point. Anywhere from 3 to 6 millimeters will get you there. And that becomes an adjustment that you want to tweak to optimize. But if you're carrying a lot of incidence, you're probably nose heavy. The next thing that Brian and I like to do, and it's not in the kits, is we have a tail boom offset. So if I lay a straight edge along the motor stick, you can see we're offset. You're looking at the bottom of the plane. Let me turn it around and look at the top. And I've got about 1 inch offset at my tail. This gives maybe 8 to 10 degrees of offset. And that gives you left rudder to make it go into a left circle. I know some of the J&H kits prefer to go in a right circle, but I found that a lot of people don't have that offset in their tail boom, and the plane refuses to circle. The next thing, as you're looking at the tail of the plane now, and again, this is set up for a left circle. The left tip of the stabilizer is high relative to the wing. We call this tail tilt. What we find is the rudder offset will help you at higher power to turn, and the tail tilt will help you at the lower power when the plane's coming down. Finally, if your plane tends to, under high power, roll in and dive to the ground, you can add a little bit of what we call wash in on the left wing. And all we do is we raise that left leading edge a little. This is highly exaggerated. And we can do that by bending the wing post just a little bit. We're flying with 0 wash in this year. We haven't seen it to be necessary. But if your plane is diving in, we tend to add maybe a millimeter or 2 of left wing wash in. And you'll see that by looking at the leading edge and comparing it to the trailing edge. And you'll see the leading edge on the left side is about a millimeter high compared to the trailing edge. So those basic setups, getting a straight plane to begin with, and then getting the CG correct, the incidence correct, and a little bit of left rudder, a little bit of left tail tilt, will get your plane in the air. And then you're making minor adjustments to that to improve your circle and improve your letdown. One of the most important things on trimming is you want to trim your incidence, trim your flying character for the letdown, the late part of the flight, not the high power. On the rubber powered planes, you can trim the high power by reducing your torque at launch. On the electric planes, you're going to have to play with propeller. A smaller propeller will not have as much power. A larger propeller will have more power during the climb up to a certain point. On the rubber power planes, what we like to see is a slightly nose high attitude during the late flight, and it slows down the use of the rubber. On these electric power planes, we found a little bit flatter of a flight. You want it to still float around. You don't want it to dive down quickly. So you want the nose up a little, but we find that on the rubber power, the nose being up a little more is where we want to be. Brian?
That pretty much is what we do too. There's one thing I could add if you're using the Freedom Flight kit. On the wash-in or the wing twist, the kit has a saddle that the wing is connected to the fuselage with, and the saddle is rubber banded on the front and the back. And then you can adjust the wing twist by slipping a shim in. So you can see there's a little piece of wood here, and it goes under the saddle. And it does just what Chuck was talking about. When that shim is in there, it pushes the wing post over just a tiny, tiny bit and adds more wing twist, more left wing wash-in. So what kits are people using? Okay, I see Josh is using J&H Aerospace. Anybody else? Yeah, AJ. Wichan, am I saying your name correctly? Freedom Flight. So you might notice that we're using the Freedom Flight kit, but we changed it a little bit. We have a single fin instead of the twin fins on the stabilizer, just a personal preference. So I don't know if the J&H kit has this wing saddle that's rubber banded on. The other thing that we have seen is the left wing wash-in, the amount of twist is a little higher for some airplanes, some Wright stuff airplanes, maybe the neighborhood of 3 to 4 millimeters. Okay, J&H does use the wing saddle. Yeah, that's really convenient. So if you shim it, well, the shim we're using is a little tiny stub of 1/64 inch thick plywood. It's probably 3/32 of an inch wide and just a few inches long, and it's sanded thin so that you can slip it in and have it adjust very gradually. I think that the only other thing I might add is circle size. The typical circle size would be 20 to 25 feet. And when we fly, we do measure them. We have one student stand on the one edge of the circle, the other student stand on the other edge. And then we either get a tape measure out or pace it off. And if you go with a much smaller circle than that, you are probably going to be rolling and having trouble climbing. And much bigger than that, and if you have drift in the room, then you're probably looking at, possibly hitting obstructions or walls or things like that. But if you have a very large room to fly in, a larger circle will generally give better duration. And then just for the fun of it, you can see on the Freedom Flight kit, if you're using that, we replace the plug-in for the charger with a switch. And then we charge by grabbing the capacitor leads with mini grabber plugs that are connected to a multimeter so that you can see the voltage charge while you're charging. And you can also see we're using the vertical motor mount as opposed to the motor mount that he recommended as maybe best in the kit, the low thrust with the motor projecting downwards. That's again a personal preference. I guess the other thing I could say about trimming in the case of Wright stuff, actually I don't think we have any Wright stuff flyers. Is anybody here a Wright stuff flyer, or is it all electric Wright stuff? All electric. When we're getting to the point where we're refining trim, so we're flying a pretty long flight, but we want to try for longer yet, it's worthwhile to test reducing the wing incidence. And usually when you reduce the wing incidence, you need to move the center of gravity back. And we'll first move the center of gravity back, and we might increment just a little more than what Chuck's team normally does, maybe 2 to 3 millimeters at a time. And we'll move the center of gravity back until the airplane is stalling towards the end of the flight. And then when it's stalling towards the end of the flight, then we'll reduce the wing incidence a millimeter and see if that removes the stall. That's generally a lower drag flying configuration, less wing incidence, more rearward center of gravity. The drawback to that trim setting is it has less pitch stability. So pitch is nose up and nose down. So on an airplane that doesn't have a lot of pitch stability, if it hits something like rough air or the rafters, the ceiling, then it might dive quite a bit in kind of a swooping dive before it recovers. So you won't know if you have made the airplane too unstable by moving the center of gravity back and reducing the wing incidence until you hit something. And then if you see that your recovery is poor, then you just have to move the center of gravity slightly forward again and increase the wing incidence. But I do think that that is maybe a possible way to increase the duration of electric Wright stuff, lower wing incidence, more rearward center of gravity. And we usually test to the extremes in all the testing, Wright stuff and electric Wright stuff. So when we're testing propellers, we'll try a 40 millimeter, 46 millimeter, 55 millimeter, a 60 millimeter, a 65 millimeter, until we see that it's not helping anymore to push the extremes. And then also probably changing the pitch of the propeller, which is challenging to do, but you can heat these with a heat gun or a hot hair dryer, and you can twist them either hard with your fingers and then put them back on your motor or with a pair of pliers. A little extra pitch or a little extra diameter will give you more rapid climb. So if you're already climbing well, like this Freedom Flight airplane for us climbs really well. It only needs like 1.7 volts to get up to a 24-foot ceiling with the kit propeller. So we are trying smaller propellers and propellers with a little less pitch or less blade area. The blade area on the kit propeller is pretty broad. But
somebody online yesterday was talking about a plane. They sent me a video of an electric plane that wouldn't climb. Is that person on board today? Okay, basically it was a I think it was a J&H, and it climbed for about a foot on the first half lap and then gently settled down. It just looked underpowered. And one thing about these motors is they're very easy to damage. That's why Brian has the pusher configuration. If your plane has hit a wall and dropped down to the floor, you may damage the brushes when it hits the front here, or the back of the motor is plastic and you may have cracked the back of the motor and you're going to lose power if it even works at all.
So there's a question about, in this pusher configuration, how we change the center of gravity. So you can probably see there's a lump of modeling clay. So when we build our airplanes, we try to make sure that they're going to come in 1 gram to 1.5 grams underweight. And then we have this lump of modeling clay that we can move back to change the center of gravity. We'll weigh every single component that we're about to use, and if we don't like the weight, we might replace it. Generally, the Freedom Plate and J&H kits and the others come with really good weight materials, but Freedom Plate recommended maybe applying carbon to the tail booms because the wood is quite light. And we opted not to do that because we wanted to save the 0.25 grams.
And on our plane, we have a switch here that's a momentary contact that they hold in until they release the plane. And then there's small wires going to the capacitor and then up to the motor. And so it's a little bit hard to move the capacitor. We got it close to where we wanted to. We have a little bit of clay on the very tail of this plane. We did on this plane have to move the wing about 1 centimeter forward from where we originally had it because we didn't want to add more tail weight. We were up to the weight. So we simply cut our wing posts off of our motor stick. We don't have the saddle that some of the kits have, and we re-glued it closer to the front to move our CG back relative to the wing.
Yeah, I forgot. You can also move the capacitor back if you don't have an underweight airplane and some clay ballast. In the case of the Freedom Plate kit or the J&H is configured, I think, with the motor on the front, and the capacitor would be about where the motor is on my airplane right now. So if you wanted to move the center of gravity back, you would have to find a way to move the capacitor back, which might mean soldering, some little slight extender wires onto the part.
When I came back, sorry, I had to step out. We're doing a real estate attraction offer right now. Somebody was talking about propellers when I came back in here. We use a propeller out of Australia on our winning design here. It's a 55 millimeter prop. We broke a couple of them. This is our last one. I ordered some props from Amazon that look about the same, but they actually have more curvature, more camber to the prop than the ones from Australia, and they were not as efficient. They were about 15 seconds less in the air. But we did play around with those props a little. You can see on here, we've added some tape to the prop, and we put it on the front and back surface, so sticky against sticky. This is just Scotch tape, and we made a wider blade by doing that. And then we can trim that blade in width. And that gave us a little bit more power, got us up to the ceiling, and it actually made the prop more efficient because it's a flatter airfoil. Even though the front end of it is somewhat curved, overall it's a flatter airfoil. So don't be afraid to mess with the propellers. We also got some 65 millimeter propellers from Amazon, and those were climbing way too rapidly. And we actually just clipped off a couple millimeters off of each tip, made sure we got it clipped evenly, and then tried it. And we worked our way down, and it's about a 57 millimeter prop now, and it performs very close to this Australian prop. So don't be afraid to cut up props if you have a source that you can get some more.
So I see you've got a question about clarifying CG. Center of gravity, yes, it's just the fore and aft balance. You don't have to balance the plane side to side. In fact, the airplane design we have, the wing is offset so that the left wing is longer than the right. So if you set it on the table, it tips over and onto the left wing. I like that design because the inner wing is flying slower than the outer wing. So a little longer inner wing is a pretty standard methodology. So it's not balanced in the roll direction. So this is roll, this is pitch, nose up and down, and this is yaw. So Wei Chen, you also had a question about center of gravity and the lateral axis. Am I answering your question correctly? So center of gravity is in just along the fuselage lengthwise. You don't have to balance the airplane doesn't balance on the wing. You can see the left wing hangs down low, but it's not significant.
Yeah, and for those that are doing Wright stuff, when you balance your plane, do it with a piece of rubber on the plane.
There's one more question here too. How do you reduce the weight of the plane? So before we build our airplanes, we weigh all the parts, and we know that the covering weighs about 142 milligrams per 100 square inches. And if you apply the glue with just careful, quick dusting coats, the spray 3M77, it should only add about 1/10 of a gram. So we know all the component weights, and we even calculate how many glue joints we have and add 3 milligrams per glue joint. So before we start, we know what it's going to weigh. And if it's not what we want, we're going to replace a part to make it come out to the weight we want. But I found that the Freedom Flight kits, the only way that one of the ways you can end up a little overweight is spraying too much spray glue on before you apply the covering. So if you weigh your wing before you start and after you start, and the glue added more than 1/10 of a gram, then that could be part of the problem.
If we've used all our, sorry, I have a question. If we used all of our lightest components and we're still a little overweight, can we shave some of the fuselage off since it doesn't have a lot of strain relative to rubber powered Wright stuff?
If you're talking about the electric Wright stuff, this is our second design, and the motor stick goes from the front to right here. Our first design, the motor stick was more like a Wright stuff motor stick. So we've got a 3/32 inch thick motor stick, which is pretty thin, and then a 1/16 inch light balsa tail boom. But we reduced the length of the motor stick and increased the length of the tail boom. So our tail moment was the same, but we saved maybe 1/3 of a gram by doing that. And you're right, on the electric Wright stuff, there's not a whole lot of reason to have a heavy duty motor stick. You want it stiff enough that the wing isn't going to be flopping around, but even this 3/32 by, I think it's about 1 centimeter tall, sorry about the mixed units, is plenty strong. It's lightweight wood. And on our original, if I can get that out, we did go back. We were overweight on this one. So we came in like right in here, and we shaved some mass out of the back of the motor stick where it's not even supporting anything. And I think we actually shaved the top of the motor stick with a sanding block. One of the key areas on our plane, because when we first built it, this was about 12 grams, and now it's at 9.5. And the key was we had some fairly heavy wire from the capacitor to the motor, and it was a stranded wire, probably about 7 or 8 strands on a number 22 with insulation. And if you can see now, we got a single strand from that wire and no insulation on it. The insulation's heavy. We've got it tack glued to the top and bottom of the fuselage so we don't short the thing out. But you don't need insulation. There's nothing going to move those wires to touch each other. And that got us from 12 grams down to 10 grams. And then we took another ½ gram out by shaving different areas.
There's a question about some flights or in some cases, the very first flight of the practice session is the longest flight. And as you're keeping charging flights over and over again, the flights get worse and worse. So I would definitely do this, use a multimeter so that you know what the charge voltage is on the capacitor. Then if you know that the charge voltage is pretty much the same, it wouldn't be the capacitor. I would suspect maybe the charging batteries, maybe are they nice and fresh? But we haven't had any issues like that. All the flights are pretty much the same if they're charged the same.
Yeah, if we're not hitting the ceiling with the same setup, we charge it back up to a full charge and fly again, and it's virtually the same time. So we have not seen that. Now, if you've ever connected your charging battery backwards, you probably should throw out the capacitor and get a new one, because that will quickly ruin these electrolytic capacitors.
Got it. I have a question about how quickly after the kids yank the charging system out do they need to launch? Like with rubber powered, oftentimes you want to, reduce your torque and do some unwinding before you launch. But with the electric powered, how critical is it to launch as soon as possible after they yank out the charging system?
Well, you want to be consistent and keep a record of what you're doing. Now, one of the things that we wanted to do on the electric was always launch with a full charge. And so we spent our time adjusting the propeller to match the capacitor to the gym ceiling height. And so with our switch arrangement, our prop is not turning until they let go of the plane. It's a momentary contact normally on, so they're holding it off. I don't know if you can see that. It's a little past the capacitor there. So they're holding a button in and it's holding that switch open. As soon as they let go of the plane, that starts the motor. So we get a very consistent start of the motor at the beginning of the flight. At the beginning of the flight, you're going to be drawing more current because you got more voltage, and think of the motor as a resistor. It's not really, but close enough. And so your highest current draw is going to be at the beginning of the flight. And if you're losing 5 seconds there, it's probably impacting your flight duration by 10 or more seconds. Now, if you're hitting the rafters and you want to charge fully and then run some time off, I would have a stopwatch so you can be consistent, unplug your charger, and then count down your launch based on the stopwatch, and always launch at 5 seconds in, or that can be a variable in your logbook. But it's like running off some of the power on your rubber. You need to be consistent. I think that's wasting power. You only have so much energy you can store in this capacitor, and you're throwing it away. What you need to do is find a way to use it more efficiently. If it's climbing too much, trim your prop a little bit. And then you want to try and launch right as that motor starts turning. But that may require you to build a switch on your plane rather than relying on the switch of the charger.
There was a question about propeller pitch. So this is a Wright stuff airplane propeller, and it's on a Freedom Flight pitch gauge. And you can see it's the angle of the blade. I think that was the question. The angle of the blade when the shaft is perpendicular to this measuring device. So ideally, you would measure the pitch at every radius, or at many different radii, to see the distribution of the pitch along the blade too, because it may not be consistent on the kit propeller like this one. But on the electric Wright stuff, the propellers are so tiny, it's a little trickier. I know Chuck has devised a way to do that.
Yeah, and I don't have the tool here right now, but what we do is we take the propeller off the motor, and we put a small shaft in the propeller as an indicator, and then we hold the very tip of the propeller against the flat edge of a protractor, and we line up that metal rod to see what angle that metal rod is sticking out at. Generally, these propellers seem to come with a pitch of around 10 degrees at the tip. But that's how we measure that. Maybe I'll go grab some tools and show you in just a minute. If you want to change the pitch of the prop, you can try twisting it, but I would recommend heating it up a little bit before you twist it, or else it's not going to stay twisted.
So also the multimeter for knowing the charge on the capacitor before you launch, we were, when we were flying initially, just timing the number of seconds that we were discharging, the charging and discharging in order to, you know, try to get consistent flights. When we started using the multimeter to know the exact voltage on the capacitor, our consistency went dramatically better. So we haven't fine-tuned our propellers yet, and on the Freedom Flight kit, we find that we're climbing pretty fast with the kit propeller. On 1.75 volts, we're at 24 feet. And if we put in 1.8 volts, we're in the girders. And if we put in 1.65, we're only 22 feet high. So it's the multimeter has been really helpful.
And somebody's asking about discharge after the flight. We go over and we turn our switch off as quickly as possible after the plane lands. And then we go and measure the remaining voltage with the voltmeter. Measuring how long it spins after it lands, you're going to be waiting a long time. It'll spin very slowly and not be using much energy at all. So that I don't think that's going to give you an accurate number.
I have a quick question regarding the Freedom Flight chargers. What is the maximum discharge time for EWS kit from Freedom Flight?
Maximum discharge time for the capacitor, you mean?
Yes. So you charge the capacitor for 1.5 minutes, for example, and then you take the charge off, you take the batteries off, and then you wait for the propeller to keep spinning until it stops. What is the maximum time?
I don't think we've ever really kept track of that.
No.
In fact, we get up to 3 volts in probably 15 seconds of charging.
Okay.
So I think absolute full capacity, you would charge a little longer than that, but we're a little behind Chuck in testing, so we're still not there.
Yeah, we typically would charge it for 30 to 40 seconds, depending how fresh our batteries were. But we charged to about 2.97 volts because our practice batteries tended to be a little bit below 3 volts. And then we would not run it at all before we launched. We'd fly, and we were running about, in a 24-foot gym, we were running about 1:15 to 1:20. And we'd immediately pick up the plane and turn it off again. And we'd measure somewhere around 0.5 to 0.6 volts remaining in the capacitor. But to run that 0.5 to 0.6 volts off, it's going to run another couple of minutes, but it's not going to have any real thrust.
Sure, right. So when you are charging the capacitor, you put a multimeter to figure out how much maximum voltage is, so close to 3 volts, before you take the charge off and throw the plane.
Yeah, and we had ours set up kind of like Josh's J&H Aerospace's newer charger, where we had a plug in the line to the batteries. So we could stop charging by unplugging the plug, but the charger was still connected to the capacitor, and the voltmeter was still connected there. So we would get the voltage in the battery without the charger battery still connected. And that's important because with the charger battery still connected, you're running current through it, and you've got a voltage drop. So, you know, if we were trying to say hit 2.75 volts, we'd charge until the meter got to about 2.85, disconnect the battery, and it would drop to 2.75 and hold there.
Thank you. Yeah, the problem with JNH is there is no switch on the plane. It's direct connect. So there's only one, port.
Well, you do have a switch on the plane on J&H. It's built into the charge jack. And you can have a switch on the plane. It's not illegal. You cannot have a switch on the charger.
So do you see this switch?
Yes.
We removed the plug on the Freedom Flight kit, the plug-in, and we replaced it with an SP DT switch.
Okay.
And it's not as slick as Chuck's switch that automatically turns on when you release the airplane. But I'm finding that the students are, so what they do is they hold on to the switch when they're holding the airplane. They just flick it and let it go.
So let me tell you about the new JNH design. It doesn't have any switch, period. Neither on the battery pack nor on the plane.
Well,
And
it does have a switch on the plane. The charge jack is the switch.
okay.
Yeah. Well, so when you unplug it, it's automatically on.
Yeah.
Yeah.
Correct.
But the new setup does have a connector in the wire close to the battery pack. And if you disconnect that connector, that's acting like a switch. That's removing the battery from the circuit, but your plug is still plugged into the plane to keep it from flying.
I've got our battery pack multimeter combination around the corner. Maybe I could show that.
Yeah.
I'll go grab it.
I'll show real quick here. Here's the propeller, and it's got a shaft in it.
Yeah.
And I'm using the protractor that's on my pitch gauge, but I just take it and place the tip right onto the protractor. And now this stick is hanging down at an angle, and I kind of slide it along until that's lining up with the angles on the protractor here. And this one's at 10 degrees, just like most of them are. And that's how we measure the prop pitch. And that is something we record as data.
Okay, thank you.
Here's our charge setup. We don't have a plug on the plane, so we actually clip these two clips to the capacitor on the plane. And then we have a plug-in line that plugs into our battery pack. I don't have the battery pack here. So they set the plane on a stand, they connect these two clips to the plane, and then they plug in the battery, and they're watching the voltmeter as the charge is coming up. And when it gets to where they want it, they unplug the battery. So the voltmeter is still reading the charge in the capacitor at that point, but the battery is no longer connected. J&H doesn't have a two-prong plug like this, but they have a single plug in one of the leads, and you can accomplish the same thing to stop your charging without turning on the plane.
Yeah, we have basically the same thing. So these are two mini grabber plugs.
Uh-huh.
So the mini grabbers, when you push on them, a little hook pops out. We grab the two capacitor leads. Then the multimeter is here. And then I just chopped the wiring and spliced in something that has a little plug on it. So this is where the battery pack has the other end of the plug. So while we're charging, the students can just plug the battery in, and then we can read the multimeter. The meter is going to say, 1.7, 1.6, 1.9, 2.0, and then they unplug it. And if they went farther than they wanted to go, like let's say they're shooting for 1.75 and it's 1.95, they can just turn the switch on the airplane and buzz a little charge off. And then they're getting to the point now where they can unplug it right exactly at the charge they want.
Awesome. Okay.
And then the mini grabbers are still attached to the capacitor, but they're quick and easy you just squeeze them and remove them.
Okay, sure. Where do I get the multimeter from? Do you also sell that from?
This was just Amazon, Amazon best, cheapest. I think it was like $12.
Yeah.
Okay.
This one's Harbor Freight. It was free with a coupon back when they used to do that.
Yeah. And then the little plug thingies are same thing. Amazon, what's it called? What are these plugs called again?
Jst Plugs.
Yeah, or I just looked up electrical, micro electrical connectors. These are not micro, but I think in the world of Amazon, they're micro.
Okay.
And then these clips are called mini grabber. And I actually bought mini grabber leads that have the mini grabber already connected to wire, and then has a banana plug on the other end to plug into my voltmeter. And then I simply cut into that lead in the middle here and added my line going to my battery. And this plug goes to my battery then.
Got it. Thank you.
Yeah, that helped a lot when we compared to us timing how much we were charging and timing how much we were discharging before launching. We got pretty consistent, but this is like just plug and go.
And it's highly dependent on the charge in the battery when you launch, on how high the plane's going to go. That first burst of 3 or 4 seconds out of the capacitor is where about half of your climb may occur.
Okay.
And if you're trying to do it with timing or by discharging the battery by running the motor for a certain time, you're not going to have a consistent voltage in the capacitor when you let go of the plane. So we ended up going to the voltmeter approach, and it was far more effective.
So Josh or AJ has a question about what switches are legal on the airplane. I know we had a frequently asked questions that we just responded to recently. I haven't seen, is it published about whether the SPDT switch is legal? Because that's what we're using.
Yeah, basically, what I've seen in the FAQs and when I've responded to FAQs, any switch on the plane is legal. And most of the kits are coming with the switch built into the charge jack, which I think is awful because it takes some force to pull that charge jack out. What you have is one person holding the plane and the other person trying to remove that jack, and then the first person is launching the plane. It's going to break airplanes. And so that's why we went to this momentary contact switch. We actually put a piece of paper in there to keep it from contacting while we're charging it up. Then when they pick it up, they take it out, they're ready to launch, they press the button in, a little scrap of paper falls out, and then as soon as they launch, it starts going. And it's a one person, one hand job by doing that. This was real easy to make. This one's a little easier to see than the other plane. It's a piece of music wire. I think that's 15 thousandths music wire. It's got a top hat shape bent on it. So when I push on the bottom, it's pushing it up. It's just glued into the balsa wood back here. And we found it was a bit too corroded to make good contact here. So this is a little tiny piece of 1/16 brass tubing soldered to that piece of music wire. And then across the balsa going this way, there's another piece of 16th inch brass tubing with the wire soldered into it. And then we have the other wire just soldered to the brass tubing here. So then we sand the surface of that brass tubing. I don't know if you can see it. It's a little shiny there. So that when the switch closes, it makes good contact in there. We did some voltage measurements with that and just the wire to make sure that we didn't have a big voltage drop across that switch.
Can we go back to the discharging after landing? Like you said, I swear you said 30 to 40 second charge. Like our propeller would be spinning forever after it landed. If we do that, do you just wait for it or do you charge while it's still spinning?
If you're doing a time charge, then you're going to have to discharge it completely. We just take needle nose pliers or a scrap of wire or even a tweezers. I think we usually use a tweezer and touch the two terminals of the capacitor to short the capacitor out, and that'll stop it instantly.
Then I had one more question. This was back a while ago, but Ryan was talking about optimal diameter. So if our diameter is too small, what is the first thing we should do to widen it, would you say?
If you don't have access to, I would order more propellers, go on Amazon and get, if you're using 55 millimeter, get some 65 millimeter. The clear orange ones seem to work okay. And then that's probably going to be too much propeller and you can trim them down. If you don't want to order some more propellers, you can do this. It's just got a piece of Scotch tape on the front of the propeller, another one on the back, so you don't have a sticky surface. 2 pieces of Scotch tape hang off the trailing edge of the propeller and stuck together, and then we trim the shape of that, and that'll add a little bit more thrust. I would rather add diameter for better efficiency, but this actually worked quite well and gave us a fairly efficient setup. And this gives it a little bit more power. This prop was not getting to the ceiling. We added these tabs and it actually was a little too powerful. So that's a quick and dirty way to get a little more power out of the prop.
I'm sorry, I meant flight diameter, not propeller diameter. Like turning radius.
Oh, I'm sorry.
Sorry, my bad. I should have said turning radius. How do we widen our turning radius? What's the first thing you would do?
So it depends on whether it's turning too tight at the beginning of the flight or the end of the flight. But first thing I would do would be to check and make sure your tip plates on the wing, and if you have tip plates on the tail, are straight. Because if those aren't straight, then you're just going to be fighting things. Then if it's still turning too tight, you might have too much angle on your stab here. And what we do is we wet this balsa wood here a little bit and bend it either more or less, whatever we need. And then we hit it with a heat gun while we're holding it where we want it. If you don't wet it, you'll probably break the balsa, which is fine. You could break it and add a little CA that adds weight. If you just wet it with just 2 fingertips full of water, then you can add some bend while somebody else hits it with a heat gun and dries it back out.
The other thing I'd watch is if you're turning too tight at the beginning and you're rolling as you're turning,
Right.
then you probably have not enough left wing wash in. So the wash in will twist the inner wing, the left wing, like that a little bit, like another millimeter or so. And that'll bring that wing up and make the circle better at the beginning.
The quickest way to do that is to take your front wing post and you just bend it to the right just a little bit, and that'll lift that left wing post. You could work your fingers carefully along it and try and bend it, or you can actually break it and CA it. But it doesn't take much. So usually you can get a bend into that.
Or if you have the Freedom Plate with the carbon wing post that has the saddle, and you can put a thin shim in the saddle.
Yeah.
And his instructions are really good for that. The other thing we will do, we're using usually a thicker tail boom, I think, than what Chuck is using. And we'll actually crack that joint. And we'll slip like a really thinly sanded shim that was a piece of 1/32 inch balsa. And it's a tricky thing to do without losing all of your settings. But generally, if you just slip a single edge blade in there, you just start to crack it, you won't lose your incidence setting and your stabilizer tilt setting.
Now, one thing I've seen a lot, especially with the J&H plane, the J&H has a carbon tail boom and it's just plugged into a socket. And it doesn't have any offset at all in the tail. It's just straight. And I've seen an awful lot of those planes that either just go straight across the gym or they don't seem to know which way they want to turn. To me, it's important that you force a left turn. I like left because the rubber world, I don't think it's critical on this, which way you turn, but you make everything work together. So we bend some left rudder into it. We put some left tail tilt into it. We've got the left wing a little bit longer than the right wing. You could even put a little bit of left thrust into the motor. We had one plane at State, there was a J&H, and it took off in a right turn did about a half a circle, was up at the ceiling, and then began to turn in the left direction. And that told me they had a thrust line problem. They had right thrust in the motor, and everything else wanted the plane to go left. And sure enough, in the middle of the flight, when it started turning left, it was kind of crabbing to the left. So you want everything working together. Forcefully make the plane, all the parts of the plane want to turn the same direction to begin with. And then you can back out of some of those adjustments a little bit if it's turning too tight. The other thing on the J and H is if you don't have a good way to put the bend up here, you can take the stab and unglue just the rear spar from the tail boom and turn that stab slightly left and re-glue that on. Maybe a couple of millimeters, 3 millimeters, just move it to the left, and that'll give you some left rudder on the stab without having to do something at the tail boom joint here.
So these are the 65s we bought. I'm not sure which ones. Did you have the same one, gem fan?
Yeah, the gem fan, the orange ones is what we had on our backup plane. When we ran out of our good 55 millimeters, we used the gem fan 65 millimeter, and that's cut down to 57 or 58 millimeters. And it behaves very similar to the Australian 55 millimeter that we're running on our primary plane.
Yeah.
And they're cheap. I think you get like 12 props for $10 or something.
Yeah, here's our propeller collection. I think I got about 8 of them in here.
Here's our propeller selection.
Yeah.
And we got probably as large a motor selection as we have propeller.
Oh yeah.
Now, the other thing to consider, if you have an early J&H or the production J&H kit and you have not purchased the what he's calling the high efficiency motor setup, that high efficiency motor setup is a 3.3 ohm motor. And that's where we ended up. I believe his production kit, or at least his early production kit, was a 2.3 ohm motor. And the lower the ohms, the more current it draws and the more power it makes. And people, I mean, that thing will fly to a 65-foot ceiling, no problem. But controlling the altitude is more difficult on that. So if you got a good flying plane and you just can't keep it out of the ceiling, you might want to measure the resistance of your motor with a very accurate voltmeter, probably not a Harbor Freight. And if it's not the 3.3 ohm motor, you may want to order that high efficiency setup from Josh. If your plane's not flying good already, then changing motors isn't going to help it that much. With the high efficiency motor, if you've got trim issues that's fighting each other, that's drag, and that high efficiency motor is not going to have enough thrust to get you to the ceiling. I actually have one motor out of Australia that's a 6.5 ohm motor, and we had to fly that for the Sony Invitational because it's the only motor we had, and it would only climb about 12 feet. But it would do, if we could get it to 18 feet by launching it real high over our heads, it would do 1:17. But it just didn't have the power to climb. And we like to launch at floor level and have it climb all the way because that gives you more time during the climb. We actually, our tallest student got COVID and wasn't able to launch it. And his partner is a very, very short young girl. And so she wore 4-inch heels to the Wright stuff competition so she could launch it higher and was able to get 1:17 out of it. But by switching to the 3.3 ohm motor in the 25-foot gym, we do an underhand launch right at the floor and just get to the girders. For regional, we had a 30-foot ceiling, and our tall boy launched it overhead, and it got to 29.5 feet, right below the light. So you can do some adjusting of the height of your launch to get the plane. The maximum height of the plane is extremely critical. Getting a little more power, it's going to climb steeply and it doesn't add a lot of time to the flight. But getting up to the ceiling and getting that let down longer is critical to the duration of your flight.
Can I share a video of a flight and you guys give us some tips?
Sure.
Sure.
Can I share my screen without being the host? I don't even know if that's.
Let's see, who is talking right now?
I'm Joshua Grisho. It says host has disabled screen sharing, so
Yeah,
I don't know
let's
if you
see.
can enable that.
I did a lot of Zoom stuff early in the year and I haven't lately. Multiple participants can share simultaneously. Okay, try that.
Yeah.
Right. I think I may have to unspotlight us too.
Yeah, probably. There we go. There.
We're good. Okay. So video over Zoom sometimes is not
Yeah.
so special, but
It's pretty tight turning radius.
it looks like it's rolling just a little bit. But what I do when I have a situation like that is I look at all of the turn settings, and if any of them are extreme, I bring them back to, it looks like the stabilizer tilt is quite significant. Stabilizer tilt can affect a lot of the flight, usually not the very beginning.
Right.
But do you know if all of the turn settings are exactly per the plans?
Unlikely. I'll wait to talk because I'm getting audio feedback.
Your audio sounds good to us, though.
I can hear myself, which is pretty much the worst thing in the world.
Oh. Yeah, it's a little tight.
Yeah, and you know, I saw you said this is the J&H.
That is correct.
Yeah, I saw one team with the J&H at our regional contest. They had 45 degrees of tail tilt. It looked like an X-wing fighter. And I talked to him afterwards to encourage him to take some of that out. And he said that's what it took to make a circle. So he had something else that was fighting the tail tilt. He did show up at state with a much more reasonable tail tilt and came in second place at state. Yeah, the two things I saw there is the circle's a little tight. I wouldn't worry about it too much because sometimes you're in a smaller gym and if you've got some drift, that tight circle isn't a bad thing, but your tail tilt looks excessive. You could take a little of that out and see how that helps. You were rolling in just a little bit. So if you add a little bit of wash in, which means get that left leading edge a little bit higher than the right leading edge, that's going to level it out. The other thing it's going to do is convert some of that speed into climb. So that might level it out, but put you in the girders. So I would do a millimeter at a time. It's a very sensitive adjustment. And that would also tend to flatten your circle just a little bit. Yeah. The other thing I saw that you might want to experiment with is it looked late in the flight like you're flying a little bit fast. And that late flight regime is what you want to trim the plane to. Now, most of my work has been with the rubber powered stuff, and I would say that's way too fast for rubber power. We have found the capacitor powered planes like to fly a little bit faster, whereas the rubber powered plane, we want them on the verge of a stall. The capacitor planes do want to fly a little bit faster, but I would experiment with your leading edge incidence, shim that up, or if it's on a sliding post, slide it up a millimeter or so at a time and check it with your stopwatch, see what that does. But it just looked like it was flying a little bit too fast at the end of the flight.
Yeah, that's all really good tips. Yeah, so a little backstory. their plane did really well at a couple tournaments, and they put it in the box and allegedly didn't do anything to it, and they got it out a couple days before that video was taken, and everything was mangled. The rear stab had the wrong tilt. It had like tilt going the opposite direction. So in low power, the plane straightened out and went into a wall, and the wing was kind of mangled too. So our girl Abby, who's on the call here, made a bunch of adjustments and everything and got it back up to a minute, but it's still quite a bit short of where it was. So we don't, that was going to be another one of my questions, was about storage, because allegedly this all happened inside a closed box. But that flight, that was about 59 seconds that we just saw. That was after a whole bunch of adjustments that were made just to get the stab back in reasonable working order. But I agree, it was too much tilt, but it had the wrong kind of tilt, and they were messing with it for a while just to get that 59
Right.
seconds.
Right. Yeah, I would get the tilt right to open up the circle a little bit, and then perhaps add a little bit of incidence to the wing, see what that does. Where's your CG?
It's at the rear wing post. I actually made a comment on this that you replied to on the Scioli forums, but it was way too far forward in an earlier plane we had, and she moved the capacitor back and moved the wing up a tad and got it at the rear wing post, and it seems to be where it's supposed to be in our layman's opinion.
Yeah, you could try moving that back another 3, 4, 5 millimeters. Move it back 2 to 3 millimeters at a time, and rather than adding incidence, move that CG back. I wouldn't go more than, say, 12 or 13 centimeters behind the rear wing post. And each kit is a little different as to where the happy spot is, but you're going to find it's very sensitive to that, and only the stopwatch will tell you if you're doing well.
So for the storage question, this is what we're doing. So there's a little piece of pink foam in the middle, and the fuselages are cut into there so that these little electric components are so heavy. I didn't trust the airplanes to just sit in the box without something to hold them still.
It's a good idea.
And I cut the pink foam a little too wide. So you see there's just like a little chunk of blue paper towel in there to tighten it up.
We use a slightly bigger box, and this foam is the computer type foam, the kind of glossy foam. And we've got a slot cut in the top of the foam for the tail boom, and a much wider slot on this one that's right on the capacitor. And the planes go in here fully assembled. And the reason for that is so when they get to a contest, they're not having to reinstall the wing and measure it. All of our AMA planes, we break them down and put them into smaller storage boxes, but you have all day to get them trimmed out. This way, we know the trim is still set the same as the last time we flew it. So you can measure it, but a 0.5 millimeter on these makes a big difference. And when you're under pressure at a contest, I found having the plane fully assembled takes a lot of room, but it's more effective, I think.
That's a good idea. So someone has a question: what happens if the plane is built nose heavy, we still want to fly the plane? How can we fix the weight? So if you can move the capacitor farther to the rear, that would help. And that would mean if you don't have enough wire on it, you may have to cut and solder in a little bit more 24 AWG wire. If you're curious to know where to get some of that wire, you probably have it around the house. I'll show you where we got ours.
Turn the power off first. Yeah, and if you're wanting to make small CG changes in the gym, just add clay to the back And if you get overweight, but you find the thing is flying well, you can then move the wings so you can take some of that weight off. But at the flying session, a little bit of clay goes a long way.
So this is computer cable, coax cable, and it's inside the bundle is 24 AWG wire. It's all curly, but you can straighten it out, and it's perfectly usable on these airplanes.
And if you're overweight with that, you could strip off the insulation and go with bare wires. The insulation is probably half of the weight of that wire.
Yeah. You don't want a lot of wire because it is pretty heavy. The other thing you can do if you want to move weight back is you can go to the pusher configuration. I guess I like this because the airplane's not hitting the floor and possibly breaking propellers, but it's still actually, we found, is breakable. So if you ram into the girders really bad, stall really bad, and come straight in, this little post the motor's on snaps right off. To find a way to make some sort of carbon to carbon molded joint for that or something. It glues back on really quick, but it's a little annoying. Hadn't figured on, you get a little 2-gram weight here, some ultralight wood, and then you slam the plane into the floor and that pops right apart. But it does move the weight back because the motor's in the back, and you can see the nose of the airplane is pretty much zero.
I did want to bring up something that perhaps I haven't seen the kit instructions, so I don't know if it's there. And that is, these motors are fairly fragile. The brushes are very fragile, but the back end of the motor is plastic. And if you push on a prop from the front, you're liable to bust through that plastic back end. And even if you don't bust that, you might do damage to your brushes. So I've trained my kids, if they're changing the prop, they're going to take a set of needle nose pliers, and they're going to grab the shaft in between the motor and the prop and grip it very tightly and not hold the plane at all. Then you can take the prop and twist it a little back and forth and work it off. So you're working against the pliers on the shaft and not pushing or pulling on the back of the motor where the brushes are. Then you put on the new prop the same way, holding it with the pliers, and you may have to slip closer to the tip to get it on all the way. But that way you're not imposing a load onto that thin plastic part on the back of the motor.
So I actually went to Dave Ziegler to ask him how to get the propeller off the Freedom Flight kit. And he told me that there was a little bit of an issue. The hole and the shaft are actually really tight fits, and the manufacturer supplies these with these props already on, and they force them on pretty hard. So he gave me a couple suggestions, and they're on so far, there's no room for needle nose pliers. So I ended up with the brute strength method, a giant blade screwdriver, and then I had to put a shim of washer in there and then just kind of twist it until it forced it like a millimeter or two. And once a millimeter or two movement had happened, then I could grab the motor and I could just pull really, really hard to remove it. So putting it back on though, I can put the needle nose on there and I can push against the needle nose so that I don't push the plastic motor end off.
Yeah, and by doing that, you're loading the brushes, but pulling is better than pushing.
Yeah.
Dydale on their site actually recommends making a tool that'll grab the back of the propeller and have a screw go in and push on the shaft. They're adamant that you're going to destroy the motor if you even just lightly push it on by hand.
Yeah. Yeah, I had one of those when I did HO slot cars, a gear puller for HO gears. I can't find it. It's too small.
Somebody's asking about the different kits. I think both of those are good kits. You've also got Guru and laser cut planes. I think the Guru and laser cut planes, I would be inclined to go with laser cut because I know John well, and I know they're easy to build. They're certainly easier to build than Freedom Flight and J&H. I think Freedom Flight and J&H with all the carbon have more robustness, more resistance to warping. Yeah, that's right. Retro RC also has a kit. I'm not familiar with it at all though. But the Freedom Flight and J&H are harder to build. I think the J&H kit probably has more generations of prop motor combinations that went into the development of that kit. But Dave Ziegler on the Freedom Flight kit appears to have reached a fairly good motor setup with perhaps not as many iterations as Josh used. So I think they're both very good kits. You know, Dave at Freedom Flight has been making his kits for a lot longer than Josh, but Josh is very persistent and scientific about his approach. So I think both of them are very good kits. My past experience with Freedom Flight is there tends to be more adjustments on a Freedom Flight, whereas J&H, he's got a setup that he found worked well and you will build it his way. And I like the increased adjustability you get with the Freedom Flight kits.
I'm going to charge my airplane up.
Is there anyone on here that does Wright stuff? Have any questions about Wright stuff instead of electric Wright stuff?
I just charged it for about 3 seconds. 1.7 volts. That's about what we fly this airplane at because we haven't fine-tuned the propeller yet. We throw the switch and launch it.
You guys know offhand, sorry.
Go ahead. Sorry.
Yeah, do you know offhand what the motor shaft diameter is? Is it 0.8 millimeter for most of these motors?
The newer Dydale motors I got were all 1 millimeter. Some of the older motors I got were 0.8. I believe Josh's motors are 0.8. You know, to be safe, I've tried to order 0.8 millimeter holes in the props, and then I've got a 1 millimeter drill to drill them out if it's a bigger shaft. But I believe the last couple batches of props I've got have all been 1 millimeter hole. If you end up with a prop that's too loose on your motor, you can put a drop of medium CA in there and then quickly put it on your motor shaft. Don't put it on too far. You want to be able to get those pliers back behind it and try and hold it square to the motor until that CA sets up. Maybe drop a kicker on it. You want to make sure you can get pliers behind it because it's really stuck to the shaft now. So you grip the shaft tightly and turn the prop. Don't just try and pull it off, and that'll break the glue joint. And now you'll have a 0.8 millimeter hole in the prop. But I definitely keep a set of small drill bits. They're available from Dave Lindley at Indoor Free Flight Supply, or you can get a set off of Amazon. 10 or 12 bucks, I think, for everything from 0.1 millimeter up to 1.2 or something like that. And I just hand turn it into the prop to ream it out to 1 millimeter if it's a small hole.
Yeah, I've been, so these 1 millimeter holes that I have to reduce, I've been putting several drops of thin CA onto each side, and then I put them face down on wax paper overnight. So the CA stays in the hole. And then there's usually enough of the hole on one side or the other that I can drill it out. And then I'll drill it with the wire size drill bit, I think, and just go bigger and bigger until it's a tight fit. I like Chuck's method better though, it's quicker. So we're back to helicopter again with high school, huh? Michigan did helicopter during COVID last year, so we're pros at helicopter.
Yeah, I was
Someone
kind of
said-
surprised. I think people have really liked the electric Wright stuff, and I think it has more to do with supply issues for Ward Scientific than it has with anything else.
Yeah.
Someone said on the forums that the reason why there was such a long gap with no helicopter was someone judged it to be too hard for the students. Is that your guys' impression, or is that a myth?
My impression is the last time they did helicopter, they had a bonus for a Chinook style, and one of the kit makers came up with a good solution to it. And I know at Nationals, we were the only helicopter at Nationals that was not that particular kit. And, you know, J&H, Freedom Flight, all these kit makers we've mentioned are not official licensed suppliers for Science Olympiad. And the licensed supplier did not have a competitive helicopter. In fact, nobody except for that one kit maker had a competitive helicopter. And I think that was a concern.
Yeah, I would think there is the current rules that are in the Summer Institute agenda. Are they probably for a coaxial helicopter?
All they say is helicopter for sea. It doesn't have
Yeah.
any rules yet. We won't see those till after Nationals.
Well, if anyone's flying helicopter next year, I'll give you a secret, super secret tip. Well, two of them. One is that super duper rubber makes a big difference. So if you're lucky enough to have like multiple years of packages of rubber sitting around, finding the one that flies the longest can be interesting. Also, the thing that a lot of people seem to miss is that besides just finding the right rubber thickness, actually density and length, you have to pay attention to the fact that the rubber becomes ballast. And it's a very fine change that makes a big difference in duration. So last year in Michigan, I think we had, I think it was like 0.54 grams per inch that was flying really well. And we tried a 20-inch length because the rubber was unlimited. A 21, a 22, 23, we thought more and more rubber, you know, that's going to be better. And it got worse and worse and worse, of course, because of the ballast effect. We ended up at 19.5 inches. And 19.5 was better than 20 by a couple, 2 to 3 flying, 2 or 3 seconds.
And we see that to some extent on Wright stuff and Wright stuff type of planes, you can put too much rubber on it. We fly a lot of limited penny plane, which is similar in size to Wright stuff, but it's 3.1 grams instead of 8 grams. And some conventional wisdom said to go with a 20-inch loop because you're a 10-inch hook to hook. And anything more than 20 inches, you start getting the knots to ball up and the rubber gets tangled. We ended up, that would be with some of the rubber sizes we were using, 2.2 to 2.5 grams. And we optimized in that range, and then we flew the same plane for another class called F1M, and that class had a 1.5 gram limit. And we were getting the same or better times with 1.5 grams of rubber instead of 2.2 grams. And I think the optimum is probably 1.7, 1.8. Now, in our case with Wright stuff this year, we're limited to 1.5 grams of rubber. So it takes one variable out of the equation. But if you're not limited on the mass of the rubber, it certainly, there's another parameter you have to optimize, including width of the rubber and then the total mass of the rubber.
Yeah, and of course, wind the heck out of the rubber motor using all the right techniques. We were probably basically loading the motors at full torque, no back off. So are there any more electric Wright stuff questions or anything, really anything?
Do you guys have a national time prediction?
For electric?
Yes, electric.
I think you'll see, well, it depends on ceiling height. The problem is nationals this year is going to be virtual. But in a 25-foot ceiling, I think you're going to see people getting over a minute 20, probably not over a minute 30. We did a minute 30 at 29 feet, but our best time at 25 feet was a minute 21. I think there's still room there, but there's not as much left in that compared to what I think we could gain on our rubber powered planes. So I would think, and the other thing is you got teams that are pushing a minute 30. Even there was one reported in California that did a minute 28, I think, in a supposedly a 25-foot ceiling. That's phenomenal. But they're not even sure they'll make state, let alone national. It's possible you could win national with a minute 20 at 25 feet. You know, Brian's team and my team are always trying to outdo each other. Our team's been lucky enough to make nationals most year, and Brian's hasn't. So we share data and so forth, and compete against each other. If he made nationals on a year that we made nationals, it would be quite a contest.
Oh yeah.
But the last time we went to nationals was Cornell. We got 508 on our Wright stuff, our rubber powered Wright stuff. Second place had all kinds of help, did a great job. He's now the record holder for youth in F1D. He got 425. So we were a good 40 seconds better than him. And nobody else got over 4 minutes. So what I'm saying is your best flying teams may not be at nationals, but I think it's going to be in the minute 30 range in a 25-foot ceiling. I think in Wright stuff, you're going to be in a 25-foot ceiling. You're going to be over 3 minutes, probably over 3:15 for the win.
Yeah, I have to be careful not to share too much because Michigan hasn't had its state championships yet. So I know what we're flying.
In a 30-foot ceiling at regionals, we got caught in a basketball support structure 20 feet up there. And we already had like 225 on the flight when it got caught.
Yeah.
That was a phenomenal flight. And they had to get the backup plane out, which they had not tested in months, and threw it in the air, and they got a 243, I think, which is what we can get in a 25-foot ceiling with the good plane. So I think we got, actually at state, we got 255 with a 25-foot ceiling. But I think most of our research on optimizing the rubber powered planes comes after state. And unfortunately, our team did not win state this year, so we're not going to nationals. Otherwise, you wouldn't be hearing these numbers from me.
That's why I can't share yet, because we still have states coming. have to keep the team data private until after states. Chuck's done with his states.
Yeah.
Chuck should be auctioning off his services to the highest bidder that's still going.
I'm giving my services to anybody that wants it free of charge.
Yeah, yeah.
I've had a lot of private video link ups with students. And that's why we wanted to start this seminar series and hopefully see more videos of planes flying so we can critique it. And if we can get some live flying going, we can actually help you improve your trim online here, and then everybody benefits from that.
Yeah, if anyone is working on their flying and they want to post questions on the scioli.org forum, Chuck and I monitor that forum and we'll answer questions along with some others. And you can post like a link to a video on that too and get some really specific feedback.
Yeah, and I strongly recommend you post questions to the forum and not to Discord, because Discord is just a pile of fluff with an occasional nugget in it. The forum, it's got a different section for each event, and it's a lot easier for us to monitor what people are asking. Discord, all the events are in one thread, and I've got to look at 100, 200 postings a day to find out what people are asking. And a lot of times I miss it. So use the forum.
Did someone have a question on the logbooks?
Says any tips on it is the question. Use it, log everything. You know, I could tell you different things to measure, and I've posted copies of our logbook. But you've got to look at what's useful for your team. On the electric Wright stuff, we measure the voltage going at launch, so the capacitor voltage at launch. We measure the duration of the charge. Of those two, the voltage is more interesting. We measure the residual voltage at the end of the flight. That tells you if you're really messed up, but that seems to be proportional to the altitude of the flight. So it's not 100% useful. We do measure the altitude of the flight, or we estimate it. Your basketball net or rim is at 10 feet. You know your ceiling height, so you can make a pretty good estimate of the peak flight height. The CG location is very important. You want to log that every flight. Your incidence is fairly important, and it works hand in hand with the CG location. So if you move the CG back, you're going to want to take some incidence out and then see how that affects your time. You want to try and adjust one variable at a time and do another flight. EWS, it's really, really easy to do because you're not winding for 5 minutes for a 3-minute flight. You can get a lot of flights in one session. Just get in the habit of recording it. You can use ditto marks when you don't change and just record the one thing you did change. And yeah, just be very consistent with the logbook. Typically, when we go to nationals, we have between 400 and 500 flights on our logbook. And I see other people showing up at nationals with the minimum required 10 flights. Your logbook doesn't do you any good at that level.
I'll second that. We have quite a number of teams when we were flying and we're winning things that want to look at our design. And the design is interesting and fun to talk about, but I would say the design is like 20% of the event. 80% of it is testing. And since I coach 4 high school teams, a couple middle school teams, the 4 high school teams typically get in about 300 flights apiece, and they share their data as a collaborative group. So the reality is each of those students has between 1,000 and 1,200 flights worth of data to use. And that's 80% of the event.
And a lot of times you'll find your first 10 sheets of the logbook are worthless once you've gone to sheets 12 through 13, because you've made changes that have been demonstrated as better, and those older flights become meaningless, but you've progressed and built upon those early flights. It's like when we design a new car today, we don't start with the Model T, but the Model T was really important for the development of the auto industry.
Anybody else have any burning questions about flight? Oh, Chuck and I are on the tech committee to help write the rules along with 2 other people for the flying events. But I do like to mention that the logbook rules that are the current logbook rules were an administrative add-on after we did the event and the airplane dimension rules. So we'll see what happens to the logbook rules in the future.
Yeah, the millimeter versus customary measurements thing is kind of interesting, especially when with ping pong parachute, you're supposed to do the height of the gym in feet, but in Wright stuff and electric Wright stuff, you're supposed to do it in meters.
Well, the interesting thing there, the interesting gotcha on that is you had to log your height, the height of your flight in metric, but most of the contests have used the ceiling correction factors in the logistics manual, which are reported in feet. So there's an inconsistency there, and we're actually correcting that for nationals. But the fact that you basically have an incomplete logbook if one item is not metric. So somebody reports their flight altitude in feet, they end up with a 10% penalty. That's been a huge issue this year. At regionals this year, I think we had 1 logbook that was considered complete, and that was my team. The rest of them were either incomplete or not present. I was pleasantly surprised at state. We had probably 2/3 of the logbooks got complete. But some people have said that the rules this year are built with a bunch of gotchas on the logbook, and we tend to agree. It doesn't help the science at all to penalize you for having the altitude in feet. But that's an ongoing gripe. The rules are what it are. We tried to get it relieved, but got no traction on that. So make sure your logbook agrees with the rules. You don't need to lose 10%. You wouldn't believe how many logbooks come with no cover page.
Yeah. Yeah, so I supervised the Boysville tournament earlier in the year, and it was a virtual tournament. There were 84 teams, 84 schools, and 162 teams that were entered. And not all of them flew. I think maybe 60 teams flew, and I think 40 teams had incomplete logbooks. So I think things have improved. That was like a late November contest. I think teams have taken a sharper look at it, but yeah.
And similarly, the switch issue on the Charger was a mistake in the rules, and you'll see a lot of FAQs concerning that switch, and most of them were me basically trying to get a rules change to allow a switch on a Charger because it was stupid not to have it. We were unable to get that changed, so you live with it, you figure out ways around it using a connector instead of a switch.
Yeah, the logbook question is a good question. So anything else burning on anybody's minds?
Okay, whose plane did we watch fly?
That was mine, Josh Grisho.
Okay, Josh, would it be okay if you sent us a PM or an email, just giving us permission to leave that in the video if we publish this video?
Yep.
Okay, appreciate that.
Hey, this is Ash. My son, Addy, he flew Joshua Finn's plane, and he made it, in my opinion, pretty well. It was a well-designed plane, and it clocked for 95 seconds. Would you be interested in watching his video?
Sure.
Sure. That's electric Wright stuff?
It is electric Wright stuff. Yeah, he's a 7th grader.
What size ceiling was that?
24 feet was the ceiling. The rafters were 24 feet, and the actual ceiling was 27.
Okay.
So the plane kept hitting the rafters because it was pretty efficient. So he watched some, Google articles and found out that increasing the CG, shifting the CG towards the propeller would help. So putting some clay right behind the propeller helped. And but that was the best time. After that, he kept getting 85 seconds and 81 seconds and all that.
Yeah.
But not sure if he can reproduce that.
Yeah, that's the best flight I've heard of in a 24-foot ceiling, that's for sure.
It is a challenge, though, to repeat a flight that if you're counting on hitting the ceiling.
Yeah.
We have a 22-foot ceiling with some really nasty girders that we have to fly at States, and it's peaked. So in theory, you could go as high as 27 or 8 if you can stay in the peak. But certain types of girders, if you hit them, you can end up in a tail slide and you can be 10 feet from the floor after hitting. So it's fun to see a flight like that. But I think I would recommend trying to stay below the girders. And that might actually mean moving the center of gravity back instead of forward and reducing the wing incidence, possibly.
Okay. Yeah. So shall I drop the link here or just you?
Sure.
Okay.
And is it okay to show that to the whole group here?
Yeah, I just posted.
All right.
Too late.
Will it run off of this into the YouTube video? Oh, I think I have to share it.
You'll have to share your screen.
I'll have to share my screen. Hang on 1 second. All right. Okay, share screen. Okay. All right, here we go. Bigger.
Wow, that's really going fast. Well, maybe it's just the video speed.
And it almost hit the ceiling, just barely. It did not actually, but it was close.
Yeah, and we found that the no-touch flights are very, very repeatable with electric Wright stuff. But once you start touching the ceiling, it adds some uncertainty to the flight. Yeah, and this is one thing that we found with the electric Wright stuff. My first impression with that plane is it's flying awfully fast, but that comes from the rubber powered background. And when you go to the electric Wright stuff, because you're loading up the propeller and that draws more current, it actually shortens the flight to get close to a stall. So it's flying more efficiently by flying a little faster. With rubber power, you've got a torque boundary condition, and flying a little flatter like this and a little faster, you're unwinding your rubber quicker, and so you get a shorter flight.
Yeah, that's nice. So
Yeah.
this reminds me of, that's my YouTube, sorry. Get that turned on.
I'm going to show something real quick here. This is from the Didel website, and I found it pretty interesting in trying to understand these motors. Basically, as you increase the torque, so you add more load to the motor, your RPM goes down. So you get a straight line relationship between the no load speed of the motor and the stall torque of the motor. So the no RPM position. At the same time, as you increase torque, your current goes up. So the power is you're multiplying your torque times your RPM, and you end up with this parabolic curve. So your power is maximized when your RPM, when your propeller loads it to the point that your RPM is half of the open circuit, no propeller RPM, no load RPM. So typically you're going to operate in this regime somewhere, but if you want a little more power, you go to a slightly bigger prop or more pitch, and that's going to move you up the power curve. To a certain point, if you load it up too much, then adding more load, you come down the backside of the curve. So there is a peak power point. And this article from Didel talks about using these motors for RC planes, where you basically have an unlimited battery and you're looking for peak power. So they're basically saying load the thing up so that in the air, your RPM is about half of your open load, RPM. But your efficiency is going to be a relationship between your RPM and torque and your voltage and current. And so as you increase this torque, your power is going up, but your current is going up too. And so you're increasing power, you're increasing current, which is your electrical power, and your efficiency goes up, but your efficiency is going to peak at something like, I think it was 85% of the open circuit, or the no prop speed of the motor. So with our very limited performance, I mean, a very limited amount of energy stored in the capacitor, efficiency is what's going to give you time in the air. Power will get you to the girder, but you want efficient. And if you're getting too much power, you don't want to go down this backside by adding more load so you don't go as high. You want to reduce your load to get to lower power and get more into the high efficiency point of the curve. Ideally, you want a propeller that in the air is going to be somewhere around 80 to 85% of your no load RPM. Actually, it's right here. It says 17% off of the no load speed. So that would be 83% of your no load speed is where your peak efficiency is. Now that's efficiency from electric to shaft power. You also have an efficiency going from the shaft to air movement, and that's the efficiency of your propeller. Generally speaking, a bigger diameter propeller is going to give you better efficiency in the conversion of rotational energy to forward motion of the plane. But this was interesting to me because I kept trying to get a little more power out of the plane, and our times were going down even though we were getting closer to the ceiling because we were getting well off the peak of the efficiency and using up the capacitor too quickly. So I had to change my motor to get the efficiency higher up on the efficiency curve and still have enough power to get to the ceiling. Now, in some cases, for example, Brian said they're charging to 1.73 volts to stay out of the ceiling. That says his motor is too powerful and he wants to go to a higher resistance motor to reduce that current curve and reduce his power when he has full voltage on the thing.
Yeah.
But if you want, just search for Didel, D-I-D-E-L, and motor, and this curve will come up, and this whole page is very interesting on matching the motor to the propeller. You have to read between the lines to apply it to our case, but it's a very interesting study. Anything else?
Ash, thanks for sharing the video.
Yeah, that definitely confirms that flying a little faster might be more efficient for these electric Wright stuff. All right, I think with that, we'll wrap it for this week. We'll probably post online again and see if there's interest in doing this again, and especially getting some more of the Wright stuff people on here if they have questions. We thought maybe we would do a demo of winding the rubber, but since most people here today are electric Wright stuff, that wouldn't do much good.
Yeah. Well, good. I think
Parting comments or?
Thanks, guys. Really appreciate your time.
Yeah, our pleasure. Look in the chat for some of the links, like the National Free Flight Society Science Olympiad resources area. And then, of course, scioli.org forum is a great place for additional questions. So I think I'll sign off then.
Thanks, everybody. It's been an enjoyable day.
Yep, that's been great. See everybody at the flying site, maybe.